I just deleted the whole thing. So are we ready, or are you waiting to let people in, or how does this work?
Yes, ma'am. I'll just get the confirmation from the team and we'll just start within a couple of minutes. All set? Start with the introduction, and that's how it proceeds. Yeah. Good evening, everyone. I welcome you all to the TechCast series brought to you by the open source community at VIT-AP. TechCast is where we bring to you the latest trends and insights from the world of technology. I am Apurva Parashar from OSC, and today we are here with our yet another latest episode, the episode 4. And we feel honored to have with us a highly esteemed guest, Dr. Bonny McClain. We welcome you, ma'am. She's a spatial data analyst, an author, a data storyteller, and a public speaker. Moreover, Dr. Bonny is a seasoned software developer, an expert data analyst, and geospatial specialist with more than 20 years of experience in the field. She has worked with numerous well established tech firms like Data and Donuts, Owner Griffin Consulting, and is currently working with Mumble Delegate Ponder, an IT consulting service which explores how human outcomes are influenced by the Earth's surface comparatively across the globe. As we know, the data revolution is here, and her expertise is tackling industry specific problems, rendering them solvable with data by relying on a wide variety of tools like Python, R, SQL, and Tableau data visualization. She's a big advocate of data literacy and a life cycle data consultant. Her exclusive ability to think about the detailed aspect of implementation makes her stand out and allows different levels of abstraction to be curated creatively and empathetically. Dr. Bonny is an incredible guide for the tech sector thanks to her knowledge of geospatial analysis that has allowed her to create effective and efficient solutions for various clients in different industries, especially the healthcare industry. Now, I would like to throw some light on today's session. Today, Ma'am is here to enlighten us about geospatial analysis. For those who are unfamiliar with the term, geospatial analysis is all about the process of studying and comprehending geographic data with detailed insights. Without a further ado, let's dive into the fascinating world of geospatial analysis with Dr. Bonny McClain herself. Over to you, ma'am.
Well, thank you so much. You did such a good introduction. I'm excited to hear what's going to happen next. Yeah, I wanted to start when I'm asked to speak about on tech topics. I see a lot of people talking about this skill and that skill, and I kind of wanted to talk with you. It's morning my time about bringing it all together, like how I bring it together, how I develop a narrative or a story, and then highlighting some of the tools that I use along the way. So I call it geospatial storytelling. And I got this ideate, collaborate, lead, I think from an earlier session of yours, because at VIT-AP, and I just loved it because you do have to think, you need to engage to have conversations, and then you have to lead that discussion. It's less of a hierarchical thing and more of a storytelling. So, what I wanted to do, you probably don't see slides like this in normal tech presentations, but I want to bring curiosity to data questions. I want there to be a wow, like a how, a what. And a story is really just how we transfer information, experience, attitude, or point of view. We all know that data is empowered to do this. We tell stories from data all the time, even if we don't know that we're doing it. And as an example, this is a painting, and I like to start with art when getting people to focus, because when you throw up like a chart or a graphic, people start panicking, like, what am I supposed to be looking at? What am I missing? What is this showing me? What colors are there? So what I like is using this. It's called Las Meninas, and it's a 1600 painting by a Spanish painter called Velázquez. And what's very interesting about this is somehow this piece of art is always used or is very popular in decoding what's happening in the larger world beyond it. And just as a way of reference, if you look here, you see this is supposed to be the artist portrayed. And there's a lot of theories on this, but this painting is to show you how we look at data visualization and the complexity and the tension that we can create visually is what tells our stories. So he's looking at this, look at this large frame here. Is he looking at us? Are we, let me go back one. Are we the people portrayed here? Is this our reflection? This is the lady in waiting. Who are these people? Some of them are looking at us. Some of them are looking on screen. Some are even leaving the frame. So what you see in this large vertical landscape image is tension and story and the opportunity for a narrative. If I shrunk it down to just a little square, it's now a portrait. And you can see if we just zoom in and we miss the details, we don't have as compelling of a story. This is me, obviously. And this, I just want to, show you just a little bit of who I am and where I'll be. I'll be at the data science, the open data science conference, introducing them to geospatial as well. That's in Boston in May. I'm also the SciPy diversity chairperson this year. SciPy is a big Python conference where I'll be doing workshops and things like that. And I'll go back to a little bit about what these books mean to me, not in a salesy capacity, but just to tell you where I saw that gap and why I decided to address it by writing books. Now, if you tell data stories, I'm also a member of the National Press Club. So I guess I'm some sort of a journalist. I like to call it a geojournalist. And really all that is a data scientist that has an extra column in her data set where I'm looking at location, because I want to see how location matters. And I'm going to show you that through storytelling, through introducing you to some SQL and other aspects of QGIS and other open source tools. Now, what I like about this article here, we all heard about the devastating earthquake in Turkey. And if you look at a journalist perspective, what you're going to see is something beyond the infrastructure. And this is to try to key your mind into how we can think about data and the stories we tell with our data analysis. So, in Turkey, there are these different regions. They're focusing on Hatay here, which was not tremendously hit in a very systematic way, but there was a very specific area that had some devastation. And, this is just a really quick scroll. If anyone wants the article, reach out to me and I'll make sure you get it. But the point here of the story is that there was a complex, a very high luxury complex that was destroyed quite significantly for various reasons that we're going to see as we dig deeper into the story. So here, highlighted in yellow, you see that geographic region. These are all seen from above with satellite imagery, which is what we use in geospatial analysis. And if you look now, you can see the building is collapsed. And this is after there's a 12-story building that collapsed in the wake of the earthquake. And the story here, and here we are rendering it this using vector diagrams generated from the satellite. So now you can see where if you look up in this upper right-hand corner where you see the legend, you can see that the areas that were destroyed are the dark. And then you have, a lot of white, a lot of, no damage around. But this area, that building was significantly damaged. And we're just going to scroll through because I'm going to talk about that. But the way they do that is they use an AI-based model that looks at images before and after, like a different pass of the satellite, and they look for change. They look at differences. They look to see what the collapses would be picked up because now there's a change in the vector profile. And this is just zooming out. And it's showing you that you could tell that near the complex, still highlighted in yellow, not as much devastation. So let's just scroll through. And now again, here it is here. And they're showing the fault line, the distance from the fault line. And this is all relevant information that you would need to be looking at location to appreciate. But the take-home message here is how this building fell was not aligned with, shaking, a seismic event necessarily. It was a combination of different things. And they share this lovely story about the compressive P waves, shearing S waves, rolling surface waves, things that are, not really germane to what we're discussing here, but they did a deep analysis. They told a story. They looked at the tension of, well, why was this building in that area that didn't seem to have a lot of global devastation? Why was this building so profoundly impacted? And what they found was, let me show you, get to the next slide. Many of these things I do, it's never. So now Erdogan, during his re-election campaign, had allowed builders to avoid some of the earthquake codes. He gave an amnesty on enforcing these zoning requirements. And in that area, that building was directly impacted. So now what the point of me showing you all this is how when you just look at something like, oh, wow, there was an earthquake, isn't that devastating? But when you expand it out and you look at the tension, like, well, why did this happen? And you can look at this, from a geospatial aspect, you realize some things aren't really adding up. And then now you have a powerful story. So now that I showed you a little bit of what the geospatial analytics have rendered in a geographic event, let me just give you a little bit of background. So we think of, when you see the Earth from space, it's this beautiful, shiny little globe floating along. And, that's nice, but it is not a sphere. It is, they call it an oblate spheroid. And it has this unique shape because of the influence of the gravity of the Earth and the way it's spins, all of that. And this influences the flow through the Earth, the magma and things inside the Earth. And this all affects gravitational pull. So the Earth sort of, this is what it looks like more accurately. And just what this means is that you're taking a non-spherical object and you're trying to decide the distance between things on the surface, which may not be as relevant if you're just using your phone to find out where the nearest Starbucks is, unless you live in, India and you want to know where it is in Guadalajara. When you start looking at larger distances, you can see how these differences can be quite significant. And we look at that geospatially, with longitude and latitude. And if you think of this as not a perfect sphere, you can see how those distances are not as intuitive as you might think. So when we look at data, geographic data, we need to pick a projection. Decide what projection you're going to use, and I'll show you this when we get into QGIS, because some of the projections preserve accuracy in some domains, like landmass area, and might lose it in others. So there's a whole series of projections. I just wanted to show you a couple that are unique in the space. And because, geography is a science, we have a couple laws. Everyone needs a law. And Tobler's law of geography, the first one is everything is related to everything else, but near things are more related to each other. And this makes sense, especially if you're looking topographically or as far as the eye can see when you're trying to do some sort of analysis in land masses. And there is some statistics that lie under this. Don't get scared. This isn't how the evening is going to go. But it's more than just a nice thing saying, oh, well, near things are more similar. There's a theory. And if you think of covariates as layers that we're going to see, that we're going to put in QGIS, which is a GIS platform, which I will explain a little more, there's statistical principles behind this as well. And of course, if there's a first law, there's a second law. And it's the phenomenon external to a geographic area of interest affects what goes on inside. So this makes sense that when we're talking about a situation with a data question, we want to look external to that geographic area and see what the influences are inside. And this could be, social, political, this could be environmental, a whole host of things that we need to think about why geography is an important layer to add to our data questions in data science. But, where do we find this data? Now, so I'm just highlighting a few of my favorite. If you've heard of GeoFabrique, it's OpenStreetMap, which is a huge resource that we use in geospatial analysis. It underlies a lot of the popular GPS things that you use when you want to know, if you're looking for amenities, like where can I find the local cash machine, where is there a bank, where is there a cafe? These things are all included in GeoFabrique, and it's global. So, it's a huge, you can go all over the world and find these, and you'll see what I'm talking about as we dig a little deeper. But you can have shape files, which are vector shape files. You can have PDF files, which are a little more space sensitive, so they take up a lot less space. But my point in showing you this is a big resource for downloading some of this vector information. If, as you see what we do with this in the subsequent slides, you become interested in exploring. Now, disaster management, this is all open source, and this is why I'm featuring this. Copernicus, the satellite system, they call it Europe's eyes on the Earth. And you can find all of this mapping data for floods, earthquakes, landslides. I was studying the flooding devastation in Pakistan, and all this data is ready for you to download. And when you go to the emergency management service, you can subscribe to it as an RSS feed. And, whenever there's something to evaluate or look at, I'm sure, I'm not assuming everyone's a journalist, but we look for data resources when we're teaching a class, when we're trying to learn a new skill. And, I suggest instead of using the canned data sets inside of some of these that are just looking at, furniture supply or business store or, some of these things, why not highlight some impactful topics that might be able to tell a story and impact how someone thinks about an event? And as you see here, the earthquake is right here and the information is downloadable. And so when you click and you come in here, you can see all the products that are available. You can just get a map, a still map, if you just want to tell a story or look at the map. You can get a vector package. Vector packages are how the data is managed. If you have, more than 2 points, like 3 points that have, or, 3 or 4 points, and you can make a connection between them. Now you have a vector, and I'll show you some of this data on a slide coming up soon. But my point here is showing you that this open source data is available in whatever product you might find applicable. And those of us that are familiar with data sets, we know how important data models are, data dictionaries, in understanding the data that we have on hand. And I love this data. This is what accompanies the data that I was showing you. It's showing you all the different types of data. It's got the metadata, it's got the crisis data, the assets. It's kind of showing you what these data sets are, because obviously when you download it, what you're getting is a whole list of files. So you may not intuitively understand what you're looking at. For example, if you go to the right vertical column, just for ease of looking at something, when I went to the area of interest, this is how I got my boundary files for the geographic area I'm interested in. I want to see what the event is built up in the Group C asset layers. It was showing me the buildings. There's also facilities, transportation, because understandably, a lot of the transportation is going to be impacted by an earthquake. Natural land use, has land use changed? What are the water systems? What does the topographic surface look like? Do we have landslides in the area? This is all photo interpretation from the satellite that we're able to look at and build data questions around. And there's also an activation viewer. This is if you just want to look at the data, click around, see what's going on. But as you can see, this is like, let's just stick everything on here and see what sticks kind of a mentality, which, there's nothing wrong with that, but you don't have the freedom. If you have, access to some of these open source tools I'm going to show you, you can do your own exploration. But through here, you can see the waterways, you can see the road network in brown. They even have some of the buildings that are on the surface. First thing I would do is come up with some sort of a data question, right? I mean, you can't do everything all at once. But what I do like is that they have regions highlighted all the way on the left in the vertical key that you see there. And when you explore it, it will give you all the information. You could add data, take data away, and maybe find out what your specific data question might be. This is all within open source Copernicus website. Now, NASA, in the US, the Earth Science Applied Sciences, they have so much open source data that people don't even realize that they have. I was fortunate enough to speak at NASA back in September. They're very open to expanding their open source portfolio. I like going in and finding the data myself, because a lot of the things that end up in the open space for you to download is not necessarily the most current. But when you're looking at disaster tools for readiness, this is, very reactionary and very just in time. And so I like this data because it is very timely and current. And we'll come back to this as an example, but I also want to show you the extent of data that you have access to: raster, vector data, different types of data that you can look at the roads if you're interested in that. You want to see the view from the International Space Station. Maybe you're looking for landslide information. Maybe you want to see the nighttime, the VIRS data, the VIRS data, which is really important because you're looking at the power grid from space and you can see where power isn't or is. And what I liked about this, if you're not familiar with Geospatial, Esri is the big enterprise game in town. But if you don't pay for enterprise access, as a single user or just like me, a consultant, you can still go in where they have their data, their proprietary data, and you can find a NASA Web Map Service Endpoint. We'll be returning to this because in all simplicity, you just copy that, stick it in QGIS, and all the data downloads. So it's brilliant, but I'm going to show you that. And what we're looking at here is there's different satellites that passed over that area in Turkey at different times. And that'll be relevant in a moment when we start looking at what that data looks like rendered on a canvas. Data scientists, those of us working in the tech space, should be familiar with Kaggle. What Kaggle offers is they do a lot of competitions, but I also go in there looking for data sets because they're always shiny, squeaky clean, and ready for business. So when I'm teaching a workshop, I rely on this a lot. And if you are open to looking at the different data sets, you can find some current information. And I shared this because I'm going to show you the tools that the Kaggle uses Python. And just as a brief, I just want to explain to you how I got into the book writing space. It's because I took Python at Columbia Food School of Engineering, an executive online class, and it was quite arduous, and I learned how to code in Python, but there was no applicability. Like when I tried to, it was just so much at once that I had to pause a little bit. And I thought, like when I went to answer data questions, I said, there is a gap between knowing Python and applying Python. And I wanted to address that gap. And that's what Python for geospatial data analysis did. What it did was, I think we need resources that don't make us all want to be programmers or developers, but just give us the tools to answer a data question that we might have at that moment. And then if we decide to expand the skills, all the better. And the same thing with the geospatial analysis with SQL. I didn't seek to make everybody a SQL expert. I wanted to give you a framework, introductory skills that could be built on. And so I wanted to share this with you because this is how I develop the books. This is how I target my presentations. And this is how I want to bring more people into the space by making it more accessible. And the book in the middle is a book in progress where we're just talking about data science and stories. So there's a lot of stories about climate change, environmental concerns, climate change, things that are timely, that have a huge geospatial and location intelligence component. So returning to that Kaggle data set, I use Colab, which is like a Jupyter notebook, but it's up in the cloud. And I use Colab Pro because I find it very, very easy to work with. So, I'm just touching a little bit on the Python side of things, but I love this notebook for these reasons. So this might look a little scary to some of you, but this is me rendering the Kaggle data inside a Colab notebook. And by just understanding the framework of Python, you don't have to be a developer to understand how tile layers have to be brought in, how we have to import packages and libraries. And from here, you can start editing this down. You don't need to make a data dictionary, a dictionary with all of the cities listed here. There's just a lot that you can learn if you have a fundamental knowledge in Python about customizing some of these notebooks. The reason I love Colab is because I can bring my data right in to the file structure here, and it makes it easy just to kind of right click, find out what that link is, put it in the data sets, into the code, and read it directly in. It's so much easier than having to, create a copy path file from your computer. And, I just find it to be very easy. You can run all the cells. I'll show you an example of some of the output. So some of the output here was looking at that satellite image. Remember I told you they do a comparative thing from before the earthquake and then after, and they're looking at the difference. And if the difference is large, they're saying, well, you know what, there's possible damage here. If it's significant enough, they'll tell you it's destroyed. And you can see this in this histogram, and they've run this through for all the cities. I just did a quick little snapshot just to show you how inside the notebook, all of this can be rendered pretty directly. And then at the bottom, I sort of cut it off. I guess you could see at the bottom, there was a statistical evaluation too that looked at how many observations there were and gave you the summary statistics of the areas. And so this is just a close-up of that sort of a thing. Gobasi, Gaziantep. So there's no visible damage there. And we're going to recreate this inside QGIS and open source. And I'm going to show you how this is we've kind of, qualified this a little bit. So now let's look at SQL database and some of the spatial functions. Now, when I work with a SQL database, and there's a million ways to do this sort of thing. This is an N of one. This is how I like to do it. I work on a Mac. And, I found a lot of things were very intuitive if you're on a Windows computer, but if you were on a Mac, you were kind of left out there to fend for yourself. So I figured out some workarounds to get this to work on my Mac, and I'm sharing those with you here. If you have a Windows computer and you go to download Postgres or something like that, you'll have a lot of different options that may even be fewer steps. But what you do is you have to download this installation package, which is going to give you a server that you're going to be able to run on your Mac and use these data sets, integrate these data sets. One of the reasons for doing this is so that you can integrate it with QGIS. You'll see this in a moment. And you can also use command line tools. I run some of the stuff in terminal sometimes. Really depends on what it is I'm doing. But when you set this up, the host is the local host. The port is always 5432. If you're working in a database, you kind of understand that that's a port. If that port's already in use, you may have to come up with another port, 5433 or something else. And you'll have a database. I'm going to show you briefly how to set this up. And then you have this GUI, this great user interface for administering your database. And I love pgadmin. It's beautiful. It's intuitive. Here it is right here. Once you upload it, you're going to have to create a database. It just walks you through all of this. You'll understand. It asks you if you want to add a new server. You'll set all this up in PostgreSQL, which was the first step. And then you kind of start working with it here. And I don't expect you to understand all this intuitively from this brief, introduction, but I'm just going to show you this, and we're leading up to that. Here's the extensions. You just add you have to add the spatial extension. You just would hit this as create extension. You find it, boom, there it is. And I have two databases. I have the Bonny McClain, and then I have the Postgres. You can create these for whatever you want and for whatever it is you're working on. Schemas, there's a public schema that's going to be your default for when you create data. When I'm teaching in an interactive environment, my schema is like when I'm writing a book. Each chapter might be a schema, or each workshop might be a schema. And because this is a database, I can give attendees of the workshop access to all the data through giving them access to a schema. Now, this is pgadmin. Now, I have to load all my data through QGIS, so this is jumping a little ahead. But if you're on Windows, you can add your data directly to like a pgadmin. I'll show you the extra step that you need if you are a Mac user. But what's beautiful here, and I'm going to show you this. All this stuff, say it's uploaded. Once it's uploaded in QGIS and I've connected the SQL database, I have now access to all the files I created over there. They're in my tables. Not that much of an extra step. It's very efficient. And because I've added that extension I told you about, the spatial extension, I now have 721 functions, which is what that red arrow is pointing at. And I can quickly look at the facilities in this region of Turkey and load it and view it right in my window using the geometry viewer in pgadmin 4. Now, because it doesn't have the palette, say, of QGIS, It's going to be monochromatic, but if you're just trying to look through these data sets really quickly to find a data question, to explore something, just to find out, we always stumble across interesting data sets that become available. This is a nice resource. And as you can see here, I came over here, I clicked on one of the polygons, and I found something. I found that there's this, it's showing me this industrial site. It's giving me a little bit of information and how it's rendered from the table. And, the data set's obviously not complete, but as you can see, this is a lot of the information that you can grab here. I could have picked a different area. This is that VIT-AP area that we were looking at. So I just wanted to show you the ease and flexibility of something like pgadmin 4. And there'll be a test on this in 10 minutes. Now, these are some of the spatial functions inside SQL that makes you think about, wow, I didn't know SQL could be useful in working with spatial data. But I mean, these are a bazillion. I mean, in all honesty, I wrote a book on it and I really probably only used 7 of these, but I'm comforted knowing that they exist. So now let's kind of go to that QGIS part I was telling you about. You may have heard of Esri and, ArcGIS and all of that. That's enterprise. And I know a lot of people have access to it if you work in geospatial in a professional capacity. But what I like, QGIS is open source. Everybody can get in there and start working on it. There's the download for Windows, Mac OS, Linux, everything. You can even install it through your terminal or your console, whatever floats your boat. I love QGIS. It's something, and it's free to use. Now, I suggest making donations periodically because it's just the nice thing to do, but you don't have to. You download it directly to your computer. And here we are. So what you're seeing here is a downloaded, we'll see what the canvas looks like a little bit as we build it out. But what you get fundamentally is this big dashboard canvas. And what you see where the red arrows pointing, it's inside this browser box. And you take the panels and you decide what you want to lock onto your screen. You could have nothing on here. I use browser, I use my layers, I use a processing toolbox. I'll show you what I put on there in my workflow, but this is totally fluid. So what happens when you open it for the first time, you've downloaded QGIS, you've opened it up, you hit new project and you're ready to rock and roll, you will have this option here, as well as the SQL Server, the Microsoft SQL Server. That'll be there as well, and Oracle. But a lot of these are, you have to pay a little extra for the spatial integration. There's, pros and cons in SpatialLite. I don't want to not mention that. I settled on PostgreSQL because it's got a very powerful, strong community behind it. And I like it. You saw those functions. You're with me, right? So when you open it the first time, this will not be here. This is the database that I created, Turkey Earthquake. So you'll get this, and it'll say create database, and then this pops up. And all you have to do, you name it whatever you want. It doesn't have to be anything. It doesn't have to match what's in the database you created. This is your unique, I'm working in QGIS name that you're going to have. The local host, like I told you, would be that it's just localhost. That's it, localhost. Just write those words, no space, no nothing, unless you have an IP address. So if you're doing this, in a workspace or somewhere else, you're going to have an IP address that would go in there. The 5432 is the default port. And I stepped through all this in the book, like how to set all of this stuff up. I just want to share it here to show you the ease. I would authenticate if I were you. Do as I recommend, not as I do. You should always get used to authenticating anything you do. And if you work in the space, I think preaching to the choir here. Obviously, if it's your own computer, you don't really need to do it. But, if you're working on a public computer or somewhere where other people have access, it's always a good idea to encrypt your credentials. Because otherwise, anyone that has access to the database also has access to your credentials. And when you run all this, you just hit test connection And if you did everything right, you're in and it set it up. If not, it'll guide you a little bit like, oh, you didn't put the port in or something like that. And this is all stuff this is workflow stuff that, when you know, you know. What I like is, what do I use here? I like saving the QGIS projects in the database and the metadata that goes along with it. And I think that's all I wanted to show you on that slide. So here's a more like your zoomed out view of what all this looks like. And this is how you would upload your data. So you would start here if you have data you want to bring into that database you created. This right here is your database manager. These are plugins. I use plugins like it's my job because it is. Here you have the Python console. You have this brings like raster data right onto the canvas immediately. This cloud data is another tool you can use to manage clouds that you're looking at. These are just very useful things. This isn't complete. This isn't everything I use, but here's quick OSM. This is how I can add buildings and OpenStreetMap data directly in, and we're going to do that in a few clicks. But what you do here is you import your layer. So you find your data. So the computer knows all the data that I have. I find it here on your computer, however you have your folders set up. I pull it into QGIS, and it's going to pull the table in. I can pick what schema I want it in. Always pick a primary key. Unfortunately, sometimes you don't have a primary key and you have to create one. That's another day. It's not hard to do. It's just a bunch of steps that you have to do in your settings to get all that set up. But it's not undoable and it's pretty straightforward. You always want your geometry column. In some data sets, your geometry column may not be geom, and you'll just have to look. Your source, you can change this. I always click these options here because I want to always acknowledge to myself that I can change it at the source here. And I like to convert field names to lowercase because I am horrible at doing that, and you'll see why when we write some SQL, how much easier your life is if everything's in lowercase. I like to create the spatial index from here. I'm trying to think what else here you might want to see. You can actually see that layer browser that I have here. You have import layer. You can export files here. And you also have those other layers. You can bring in a geo package. And this is just a close-up of what I was showing you before, how we pulled all that stuff in, what I like to check off, and how I customize it for myself. And this is what that screen looks like. Obviously it's a little bit of a there's everything going on here, but what you're looking at is a vector layer that's categorized a building feature class. So what we've done here is you're looking at an area of Turkey, and we're looking at damage, destroyed, no visible damage, possibly damaged. The black, these are destroyed. The red is damaged. And I'm able to layer style this and change this and render this in any way I want. I made the buildings pink little houses, the ones that I can track and I can see. The green means something different. So it's totally customizable. You're not going to learn this from, sitting with me here for an hour, but I just love highlighting the features that are available in the open source geographical space. And just a reminder that if you use Jupyter Lab or you use Colab or any sort of notebook for bringing in your files, you're going to notice that you have to package all the files together. You can't just pull a shape file in. It needs all these co-packages. When you're using QGIS, if you drag your shape file right onto the canvas, you're done. Everything goes where it needs to go. And I'm taking a little jump here to show you. We talked about plugins. They're up here. This is the toolbar in QGIS. And as you can see, just for orientation, we already looked at these, right? And here's the OpenStreetMap. It shows up under vector. It also shows up under, a couple, it's cross-tabbed. And this here, the view here is how you create your panels and what you want to have on your screen. Very simple. I feel I have set up videos also of where this has been done. But this is just a highlight. Like I just did a preset of building. There's so many other things you can look at. You can look at roadways, waterways. You can look at land use, which is really big. I'm going to be looking at land use in Boston when I present there. And we're going to be looking at zoning and the built infrastructure and examining social inequity, just to highlight really the way that we can apply geographical location to storytelling. So here, and so, for earthquakes, sometimes looking at roofs, looking at a roof shape is all we have when we're trying to figure out how these things, differ from time and location, pre-event, post-event. But this could be anything. And what I'm showing you is this right here can just be populated onto your canvas in QGIS. And this is showing you all the vectors, the multi-polygon, the multi-line, the point data. This is all an example of vector type data. So I threw everything here just for examples, but you're looking at dots, points, and this is all important because you can do SQL analysis and write equations, syntax, so that you can evaluate this even more. I just did a rendering of a map of the area so you could kind of just get a broad idea. I don't think it's a good idea to put everything on the map all at once necessarily. And this is that region we looked at in the histogram that showed very little damage. And what's interesting, if you do a point classification of it, now we know exactly where those areas were that were damaged. These little points represent those possible areas. So this is the area of interest polygon that I was able to generate from that free open source data set. And now I'm looking at all these areas where there was no visible damage. And obviously, if this was a live dashboard, you would have the ability to zoom in, zoom out, look at different regions, figure out what's going on. There are a couple places where we do have destruction that we see here. Maybe we want to explore a little different, maybe we find, zoning or permit issues or whatever we want to tell in our data story. And those three regions are highlighted here on this bigger map. This one's kind of buried under all the buildings. There's more here. There's more here. What you're seeing here is that building data that I added from the OpenStreetMap data. And then what I wanted for a more timely look is I went into GeoFabric that I introduced you to earlier as a source of vector data, and I pulled all of that in, and that's what you see here. So that's added in this bottom layer as well. Now we get to some SQL, and this is just from chapter 5 of the book. And I just wanted to highlight just a couple of the spatial concepts that are in here. They're all like throughout the book, but I thought this was a good chapter just to do a brief introduction of how we use a query-based syntax. What I like about SQL that's different than Python is, besides the annoying deprecated, you get all that when you try to run Python code, SQL is kind of conversational. And I like that because really the simplicity of it is, hey, you know what? I want to select some columns of data from this table, right? The table would be something you upload it to the database where this is happening, this condition, this thing that I want to look at. And you'll understand an example of a where condition in a moment. But really just understanding the foundational element of how to write a SQL syntax takes you a very long way. The best way, and this is why if you look here, the columns have to be entered exactly as they are in the source data set, exactly, which is why I recommended that you put everything in lowercase. But when things don't run or it doesn't recognize the data set or it can't upload it, this is the first place to look. Live it and learn it. These are not SQL spatial queries, but they do explain to you how basically you have all of this ability to pull data out of your data set from this column, not that column. This response, not that response. You have numerics, you have integer functions. You can pull things from your table in a specific order based on a specific value. So I like to show this because when you do this asterisk, you're getting all of the data in. And here's an example from the book. We were looking in Brazil at deforestation. And what I liked about this one, I put in what the query looks like. The query looks geometry, ST buffer. So, and then you have to put in what your geometry type is, the radius of the buffer, and then buffer style parameters. Now we have to figure out, what does that mean? And that's kind of why I wrote the book as well, because you would get all these free manuals of how to do stuff, which is great. But when you look at that syntax for writing a query and then how you actually write the query, I felt, maybe this is just me, but I felt there was a bit of a learning curve too. And so I thought maybe the books could address that bit that can get you from, the data manual for the tool and to being a little more independent and bringing in your own data and answering your data questions. So, this is basically select by my unique ID. Whatever my unique ID is in the data set, this is what it is in the data set that I use to look at these areas. And then I'm buffering around a distance around the area that I'm looking at. And this is really, really important because based on, your projections and your SRID and choices that you make upstream, this is going to be as degrees or as meters. I don't think degrees, I don't know about you, but I don't think, oh gosh, what's 50 degrees from where I'm sitting? Yeah, I don't think like that. I want to know meters. So you have to pick some sort of way of looking at your data, changing the SRID so that it applies to how you want to look at your data. The from part here is just, this is the table. And the chapter 5 that you see here, this is my, this is how I have my data set up. So, each one of, I didn't use the public, I used a one that I defined, and there it is. And then here, where protection. So now I'm saying there's a column, and the value in that column is the data I want. And I want it to be this reserve, this protected area inside of this area. And you can see that buffer zone. Just with this simple code written here, you can see that. And now the great part is you go back to Database Manager and you click here and you can write your code right into the window that opens. So here I am, I'm selecting all, this means all. I'm selecting all from a particular area. I want all the buildings, and I want all the buildings. This is a column heading right here. So here I'm asking my column where, here's the column, and the value is destroyed. And do you see here how I had to enter it exactly how it was? If I put a lowercase d, I would not have been able to pull that up. And that's why it's always good to kind of, this is a mess. Normally I would clean this up so it's the name's not so long, it's not uppercase, lowercase, because if you have everything lowercase, you don't even need the parens. And that's always nice. But I'm showing you here, here's your geometry, here's the ID, the object type, these are residential, the area, and I'm going to load it as a new layer. So I've run my query, I'm running it, I'm executing it. I have 68 rows. I'm going to add a new layer, and it's going to be in my QGIS. And then you just have to update the layer so it shows you. So the layer that we had in there before, now that I've run a SQL query, it needs to be updated to reflect the question that I asked. And so now this is what happens when you update the layer. the column with unique values. It could be the ID, it could be the UID. It depends on what your table looks like. And this could be customized. I'm just calling it query layer, but it could be whatever I want it to be, excuse me. So when I run that query layer, this is what I'm left with. So these are just showing me the destroyed buildings in this area in VIT-AP. So now I'm looking at the data. This is just what we were looking at before. And I want to show you this. I run the filter on it, and now we're looking at what the data looks like. And I'm seeing something very interesting here, because you should always look at your spreadsheet. And what I see here is these are unknown areas. I don't know why that is. They could be this area. They just weren't, qualified. I don't know, but I really don't want them in my data set at this point. So how do I adjust the query so those aren't included? Well, what I do now, because remember, I'm picking this column and I want destroyed, and I want to look at that ID where it's 994, because where it was 1, it was unknown. I also could have queried name unknown. So there's different ways of getting that data that I want. This is just saying that it's a subquery. So in case I keep querying and querying and querying, these things are sort of organized for me. Here's the query layer. Remember, I did not customize it. Perhaps I should have. I did not customize it. So there's just the standard query layer. But now look, I don't have 68 rows. I have 44 because I've cleaned up my data a little bit. And here's what we had before. And now here's what we have now. I changed it to hashtag, so it's the hash in here, so you could see how different it looks. This is the updated SQL query where I eliminated anything that said unknown. And this is back to those other connections. I put this back in because I want to show you that web map service endpoint that we saw earlier on the Esri side. This is the REST services directory, but you can find data that's proprietary, and there's portals that you can go through to get a lot of it for yourself without having to be a proprietary user of the platform. And this also gives us some information. What are we looking at? The color variation from pale yellow to red, more significant damage based on the radar reflection coherence in this synthetic aperture radar, the Sentinel satellite. And you'll see this on the QGIS canvas. There's color vision deficiency in standard version CVD or standard version, because you'll see some will be depicted in blue and some are depicted in yellow to red. So it's important to understand that these are just different satellites. And then you have your date range. So there's a lot of important information here that we really don't want to just click through. So when we're over here, back in that browser, this browser, I don't think I mentioned. So this is what looks like what my workspace often looks like. These are the panels I decided to add to my workspace. I have the browser. This is a hierarchical. This is your computer folders. If you open this up, it'll have downloads. However you have your data structure, this is where you find it. And then some of these things are just here natively. And then your layers, so all the data you add shows up as a layer in the layer panel. Here's the layer styling. Remember I said I kind of changed the fill on those polygons when I did the updated query layer, which you see here, and then layer rendering. And then I also have a processing toolbox for where I do my analytics, but that's blocked. I can't see it because I have my face. But so here's that web map service. And you see it over here. I just kind of busted it up so you could see it better. That's that link that I shared with you. You can just name this, whatever you want to call it. You put the URL in here and you just run it. You just hit enter. You're creating a new connection They'll give you an option like a new connection, edit a connection. I forget what the other one is, but it's very intuitive when you get to that part. So, and all I did when I hit it, it loaded right in here into this, into my browser, and then I just dragged it down into a layer. Or I think you can click on it and it says add layer to project, and now you can see it. Remember, here's that one pass of a different satellite. The dark blue is going to be the areas impacted. Here is the other satellite that came through. And I don't know if you can see it, but I also added tectonic plates. So we can look at locality, how close these areas were to the actual tectonic plate. This is the area I was focused on before. That's also the area where we saw that building in the news story from Financial Times. This is just another close-up. Here's that area again. You see there's not a whole lot that you can see from this level, but you click in and you can see some more of these assessments that are rendered at that level. And, this is, when we zoom in, you can see those polygons. These are those building polygons, but now we see something very interesting. We can see some damage under some of the polygons as well, but this area is so devastated, it doesn't even register as a polygon. So it's very interesting, how you can tell the different stories. I want to stop here to give us plenty of time for questions about, geospatial, how I do my work, those sorts of things. And I'm ready to take any questions. Do I stop sharing my screen? I'm not sure.
Hello, am I audible?
Do we have any questions?
Ma'am, thank you so much for that amazing session. We got some questions from the audience. One of the questions was this field of geospatial analytics. When we look at it from the context of computer science students who are currently pursuing their BTech degrees, how would you say that it is relevant to them in terms of like perhaps a job perspective or a resume perspective or even just a hobbyist perspective? What skills do you think it will really highlight by getting into this field, dabbling our feet into here?
It's really, really, obviously it's really important. No, this is a extremely fast growing field in terms of the applicability, because never before have we had access to this type of data. Like Google Earth Engine is just ginormous amounts of information that people are going to want to be able to render with their data stories and it's just a huge big growing field within data science in general, and specifically in a lot of the types of works we do in community planning, in the federal government. I tend to look at social inequity at the community level or the city level. When you're working with census data, which is big, this is humanistic data. This is telling you where something happened. It's a multi-billion dollar industry that needs people to tell the stories, needs people to do the data. Python packages are growing exponentially that can show us time lapse, that can show it. I didn't show it here, but it's very easy to show this across. Anyone learning skills at this stage should add the geospatial science part to it. Otherwise, you're really just looking in a linear fashion, whereas when you use geospatial analysis, it's cinematic. It's how we tell stories. You can just look at the Financial Times article, look at the New York Times. Every major storytelling platform is showing you. It's not just telling you, it's the showing aspect. And it adds to credibility. And to tell you the truth, it's just a very interesting way to approach science in general. And the fact that it's got such a large open spatial community, open source community, is also very powerful.
Thank you, ma'am, so much for that answer. It's very elaborative, and I just like to say one that way you're saying that data analysis, it's storytelling. That is, I believe, one of the best analogies one can say in this field of analysis and data science, because you're telling stories using just raw data, explaining what's happening, predicting what's going to happen next. So, thank you very much for your answer. We have one more question from one of my colleagues here. Chandana, would you ask your question?
Hi, Bonnie.
Hi.
So you remember me, right?
Yes, hi.
Yeah, so I'll be asking one of the questions. So you have told about so much about geospatial analysis as of now. So we would also like to know the limitations or the challenges that the geospatial analysis faces in the real time.
Yeah, you touched on it a little bit in the earlier question in looking at, probabilities. And that's what it is, but it's another tool, because when you just do data analysis on its own, it's very biased, even if you're looking at raw data, because I make the decision as a data scientist what data I'm even going to bring to the question, right? I can pick this data set, not that data set. And that's why, with storytelling, you have to be able to have attention, meaning that you might bring data to the conversation that doesn't support what you personally think. So understanding the bias built in, like we all know, into AI and machine learning, being more transparent is always the best resource and the best skill set to have. And what's more like transparent than visually showing someone something? Now, I could tell you that Erdogan had questionable zoning political policies around trying to get reelected. And that sounds very partisan. It sounds very subjective. But if I can show you a geographic region that was like not devastated by normal geophysical attributes of an earthquake, but now I can show you where the zoning changes were and weren't, and you could see a building that just crushed and killed uh, dozens and dozens of people, that has a certain objectivity, and we need to be able to deal as close with the probability of a truth that we can. And a challenge facing geospatial is probably the limits that we put on ourselves. A lot of people don't harness the true opportunity like at our fingertips. We get in our own little silos, and we think, oh, I just work in hydrology, or I work in the utility sector, or I work in, and we don't realize the bigger picture at play and the power of the storytelling. So I think we have more people getting trained up in the geospatial communities. We have a lot of open source tools, but a lot of these open source tools kind of fill people with trepidation. They're intimidated by learning a coding language because we put up these little barriers to access along the way, maybe intentional, maybe not intentional. But when somebody, and I try to be that person that can sit back and say, hey, if I could do it, anybody can do it. I'm also an ultra runner. So, when you do these huge races, if you're running 50 miles, you can't go out there and think, well, there's mile 1, here's mile 2. What we tend to say in the ultra running community is, how do you eat an elephant? And we say 1 bite at a time. You have to start somewhere small and build and grow from there. So maybe we have a computer science person that's picking up a little coding that thinks about, well, you know what, I would like to look at a visualization. I would like to do matplotlib and look at a map, or I would like to use SQL to render this vector data in a visual canvas so that I can maybe engage in conversation. So those sorts of things I think are very, very relevant. I really think the sky's the limit. Like anything we do creatively, you kind of need to explore different topics to find and learn about things that might be able to be explored geospatially, if that makes sense. And now that we have these huge, like QGIS about maybe 5 years ago, this open source alternative to an enterprise platform was kind of clunky and not as intuitive as you might like it to be. And as the community has grown, it's now this very usable, and it's evolving even as we speak. And, I'm invited to speak as a data analyst, but I always show up as a geospatial analyst because I think leaving that location column out of it is limiting the power of the data that we're kind of liberating from where we're finding it, resourcing it, and accessing it. Does that kind of answer your question?
Yes, that was a very good answer to become a geospatial analyst. The very it would be good to take. So the next question is, would you recommend this field or this venture to for beginners? Suppose like to put up a startup or something like that.
Well, so you're asking me where do I suggest for people that are trying to get started? The open source community is very open and vast. If the lower left-hand corner of the screen has my Substack it's got a lot of free content in it. It was created from dialogue about the 2 books that I wrote because people have a lot of questions. They read a book and then they're like, well, now what? So we created this little community over there on Substack, and I don't answer all the questions there, obviously, but I point to a lot of resources over there of where you might want to start. And it really depends on the kind of learner you are. Not everybody can pick up a book and learn how to code. Some people like to look at videos. If you're looking at videos, there's none better than Chu-Sun Wu. He is over on Substack, and he works in the Google Earth Engine community. So if you go over to, I should have had him on a slide. I don't, but you can reach out to me and I can send you how to get a hold of him. He's over on LinkedIn. He's just brilliant. In fact, true story, I saw his video years ago where he presented at a Python conference. And I don't know how I found this video. It was an hour long. It was over on YouTube. And I was hooked and mesmerized by it. And a year later, just based on like watching his video and spending all my time learning everything I could about geospatial, I presented at the same conference. So the road isn't all uphill. It just takes a lot of passion and a lot of interest. If you look up Google Earth Engine and Python as your search in like Google, you will find him, and he has dozens and dozens of videos. If you're a visual learner, he also has a book that was recently published by the same publisher as my 3rd book that'll be out later this year, Locate Press. And I believe a lot of, he blogs. There's a lot of stuff out there. I just highly recommend thinking about what kind of learner you are and starting somewhere. Join the community. Joining the community is powerful. Every Wednesday, I think the time may be prohibitive to you, but every Wednesday at 1 p.m. New York time, a whole bunch of us, people in Geospatial, gather in Twitter Spaces, and just kind of yuck it up, answer questions, talk about different topics that we have, and we record it. So if you join it's called hashtag Geospatial Connections, plural with an S. If you join the Twitter space, you'll get a recording after we meet live. And there's lots of resources there, lots of opportunity to reach out for, help, or we put people in jobs. It's a very active, a small and curated community, but filled with many of us that have different areas of specialty that I always like to point people towards. I think if you look at my Linktree link that's right over here, I think I connect to everything here. Substack, I think I link to the geospatial thing. There's lots going on there that if you want to find your next step, I think you could find it there.
Thank you so much for the answer. We really appreciate your time taken to answer this question. Now, I would like to hand over to my colleague Jay, concluding. Thank you.
Thank you for asking me to be part of this. This has been great.
Thank you so much for that answer, ma'am. There is just one last question we have from our audience, and this is a more personal one. You've obviously worked on a lot of different projects before throughout your career. What would you say is the most interesting project you had? And could you elucidate on the challenges you might have faced while you were doing it? What made it so interesting?
This is a good one. Okay, I'm going to answer it in the space that we have in case there's a further question that comes from it. As a data scientist, and I work a lot with census data, I'm often asked, could you pivot this data set by race? And I was always like, why? I mean, I wasn't being cheeky. I was like, what is that going to tell you? It's a social political construct. It's not a biologic proxy for anything. And I was perplexed because, we have these questions about our built infrastructure, about our communities, and people kept using race as a placeholder for something else. And when I discovered that I could start looking at other things that were more telling, more boundaries from a zoning perspective, from who's allowed to live in this area versus that area. And, this is global. It's very specific to my initial work using the census data, was looking at, who lives in communities where the properties are rental properties. They're not owner occupied. Where are people who lives in those communities where there's not a walkable sidewalk, where there's no green spaces, where there's parking lots, where there's urban heat islands because we don't have enough tree or green space, or where you can't get to a supermarket. There's no transportation. If you get on a bus to work, it may only be 2 miles away, 3 miles away, but it might take you an hour and a half to get there. So I started looking at the infrastructure and the land use in areas to answer these questions about social inequity that we used to kind of put a pin in and think they were racial. And now if we find out that they're built on structural problems and in our infrastructure, now we can legislate, right? Now we can introduce solutions. So that has been the most powerful part of the work that I do, looking at zoning. And just to close, like on a very specific example, if you look into a community, and I'm not going to mention communities by name because the nature of the time we have, I can't give it both sides of the coin, but there's this movement called Not in My Backyard, and then it's called Yes in My Backyard, meaning people through zoning can restrict multi-dwelling units. So I don't want renters in my community. I don't want, insert whatever you want to put there. I only want people that can afford 7,000 square foot lots. I don't want the lots broken up. These are other ways that we can influence who lives where and who's part of our community. And that part of it, once I set things like gender and race aside and started looking at actual measures, I can start looking at social inequity in a very different way. And that's only through looking at geospatial information. So thank you for that question, because it's a perfect and beautiful question to kind of wrap up why I call myself a human geographer to begin with. So thank you for that.
Thank you so much for that answer, ma'am. I'm just feeling off the vote of thanks. First of all, thank you for coming to this TechCast. You've taken time out of your busy schedule. You've prepared this entire PPT. You've gone through the entire context. And in data science, we say that statistics don't lie. Data always tells the truth. And well, our statistics say that our listeners found this entire episode extremely engaging and informative. Got a lot of questions. Couldn't ask all of them due to the time constraint. But thank you for taking the time for getting all of this together and telling us about this very interesting field. As personally speaking, this field itself, it has two of the most special things for a lot of students, I feel like. One is the geospatial aspect, and the other is, of course, programming. A lot of people here are programming students, they're computer science students. So this really whispers to them, it really talks to them. So I
But I like your quote. I want to give you a quote from my email signature about statistics. It's not my quote. It's from Hashish Mahajan from the Landsat Journal in 2007. Here's what he says: statistics are like swimwear. What they reveal is suggestive, but what they conceal is vital. So I love that one. So thank you so much.
thank you very much, ma'am. I'd also like to take time thank our faculty coordinator, Dr. Ashish Kumar Talai, without whom this would not have been possible, and of course the wonderful people here at open source community of VIT-AP, the executive board, who have gotten this entire event together. They're the ones who are working on the background, backstage, organizing everything, making sure the live stream is working perfectly, reaching out to talented speakers such as yourself, so we can spread the information to as many people as possible, get this field out to all. So thank you everyone, of course our audience, for tuning in. You've also taken the time. And simply speaking, we hope you learned something very interesting, very new, and perhaps it gives you a little food for thought on what you're going to go and learn about today. So thank you for that. Over and out.
Thank you.